I'd like to share with you my passion for one of the most amazing shapes in the universe. It's called the vector equilibrium. It's basically this shape. It has another name called the Cuboctahedron. It's a kind of a compound of cubic and octahedral information. And this was put together quite well and passionately by my mentor called Buckminster Fuller. And so there's many sacred geometry teachers like myself. We just have been so inspired by the works of Bucky and another colleague of mine called Marshall Lefferts. There's a whole book dedicated to the vector equilibrium. It's in Cosmometry, which he sent me. So I was just amazed about how much information there is in the 12 around the 1. So what I would like to start off with is I'm going to show you how much information, all these numbers from here to 12, 13 to 480, all this number information is embedded in this one shape, and that this shape is superior or more elegant than the basic cube, which only contains a few important number codes and axes. So this is not to say that it's better, it's just that it's more compact in a way with knowledge. So to get the Cuboctahedron, what we need to do is we need to think of not just the hexagon. We know in the two-dimensional plane we've got the 6 around the 1. That's called the seed of life. So when we line this up, you'll see that we've got the hexagon. So let's draw the hexagon as spheres. So we've got 1 in the middle and we've got the 6 around it. So that's called C7. That's the carbon 7 molecule, which is the key to our technology. But instead of 6 around the 1 in 2 dimensions, what would be the 3-dimensional analog, where if we have a central sphere, right, we have a central sphere, we put 3 above it and we put 3 below it as well. So they all fit in what they call to the valley. So these 3 are sitting not on top but in the valleys. So this is called the 12 around the 1, where all spheres are tangent and touching. So the key is number 13. So even though it's about number 13, which is one of these numbers here, these are the 12 spheres, it's really about how it's centered around the number 1. So when Magic Spider goes in to the 12 around the 1, which has got to do with our cosmogenesis and the beginning of our creation, microbiologists discovered that every form, before the zygote separates, before the 1 becomes a 2, we have the 12 around the 1, which sets up a universal grid. So I'm calling this vector equilibrium. The vector equilibrium is a universal grid because it has a lot to do with the beginnings of creation, and it's also to do with atomic structure. So if we just looked at a cube, a basic cube, which is here, when we study the cube, we can say it has an X and a Y, and the vertical axis for depth is the third axis. So X, Y, Z gives dimension to the cube. So that's the number 3 here. So we've got number 3. And we know that the cube has 6 faces. So we can say, yep, it has 6 faces. Or we can count the corners, it has 8 corners or vertices. And then if we counted all the edges here, yep, it has 12. We can say it has 12 lines or edges, and all these are 90 degrees. So 4 times 90, so each face has 4 lots of 90 is 360 degrees. And if we multiply that 360 by the 6 sides, we get another cosmic number, 2160. So you can see that the cube embodies a certain amount of information, but what I'd like to show you is that this vector equilibrium, the cube equilibrium, is the most balanced shape in the universe because it holds so much data. Because under compression, it forms an octahedron. But before we get to this natural fluorite crystal here, which is this one here, that's what's inside the cube. So what's inside the cube is 8 triangles of the fluorite crystal. But before we get to that, there's a half compression. So we'll call that a full compression. So when I went from vector equilibrium or Jitterbug, it does the octahedron. But if I went halfway, and if you can visualize that this join is the same as the edge, it forms the icosahedron, which has 20 triangles. So this is the icosahedron here. And the beauty of the icosahedron is that its shadow, when you shine a light, if I got a torch and shined it on over this, you'd see the hexagon here and also the pentagon. So this is the pentahexa shadow form that is seen in DNA. So that's why this is really special. And the other reason why vector equilibrium is really special is because I call it the most balanced shape in the universe, because it's the only shape in the world or the universe where the 12 interior vectors from the center to the vertex, there's 12 actual radii. And that distance, if what I'm touching there's 12 of those, that distance, we'll call it a matchstick, is identical to the outside lengths. There is no other shape where the inside is the same as the outside, and it's a form of fractality. And fractal can only relate to the golden ratio, because when we compress the cuboctahedron, it's shifting from the hex view to the pent, because the icosahedron, this icosahedron is all based on the golden ratio. So even though this is essentially 4 hexagons, 4 rings of hexagons, we can see that it's actually undergoing, it's shifting from the hex to the pent. So that's why I call it pentahexa. And the only way I can show you the 4 hexagons, if I have 4 circles and I open it up, though we end up with what's called 6 squares and 8 triangles. So this information of there's 4 rings. That hexagon is like one of these circles, but there's 4 hexagons. So its coding is called 6666. But if I wanted to express this as a geometry, at any vertex here that I hold, at that point there you can see 3, 4, 3, 4, because triangle, square, triangle, square. So that point here means that we can call this shape the 3, 4, 3, 4 shape. So just to conclude in the last few minutes, what I'd like to do is I'll just quickly go through these numbers to show that so much is embedded in this. So we know that 1 is the center, but essentially the center point here is the zero field. It's a unified consciousness. So people give it a name, it's called the zero phase. And because these 12 vectors are emanating from this center point, we call it omnidirectional. Omnidirectional means the 12 vectors are going in all these spaces at 60-degree angles here. So we've done the 60-degree angle. We've shown the zero center, the unity sphere in the middle, and all these points are opposite. So when we look at this point, I'm holding 2 opposing points there. And I'm holding a hexagon over here, so there's a hexagon there, but like I said, there's 4 hexagons here. So this is showing the diametrically opposite points. We know that there's 8 triangles in the, when I count the triangles, there's 8 of them. And at any point, you know how I wrote 3, 4, 3, 4, that means that at any point here, not only do we just have triangle, square, it means that it's a 4th dimensional geometry in a higher world. This is 4th dimensional geometry because it's perfection at all scales. And when I say at all scales, I mean the microcosm of the atom and the universal galactic scale. So this 3434 code says that at each vertex we have 4 lines connecting. So if you look at this point here, I've got 1, 2, 3, 4. And it's 5 because under compression, the number 5 is embedded because even though it's 6ness, when we compressed it halfway, we got the icosahedron. So the Pentagon mysteriously was formed, and that's one of the greatest gifts of the cuboctahedron. 6 is because we've got the opposite pairs, and we've got square-based pyramids, which means from this square there's a pyramid going to the center here. I should have, it looks a bit like this Egyptian pyramid here. So there's a square face, but they're all touching at the center point. So we've got 6 square-based pyramids. We've done all these. Carbon 7, we mentioned it. We've got 6 points around the central molecule. 8 because there's 8 triangles. 12 because there's 12 around the one. We've done that one. And what if Magic Spider goes inside of this form? If Magic Spider says, I want to connect all the the 6 and the 8, the 6 squares and the 8 triangles, that's 14 points. If magic triangle goes in there and joins the 14 points, it ends up with this shape called the 12 diamonds. So the number 12 is the 12 diamonds. This is the jewel of the vector equilibrium, because it is number 12, but they're not in the golden ratio. They're in, if this is 1, that axis, this is root 2, 1.414. So it's 12 diamonds in the root 2 ratio, and it makes the thing called a crystal called garnet crystal. So I'm holding a raw, unpolished garnet crystal, and you can just sense some form of diamond shapes in it. But when I show you the polished one, you'll see that there's more distinct diamonds in the root 2 ratio. So this is good to know that the jewel, what lives inside of this shape, is the it's the 12 diamonds. It's got a name called the rhombic dodeca. So we've done all of these. We've seen the 13 spheres. We know it's got 14 faces. That's 6 and 8 squares and triangles. Now that number 20 is interesting because that's the number of volumes. The tetrahedron, there's a tetrahedron and there's also double tetrahedrons, but this tetrahedron that fits into the center can fill the volume of the mother form 20 times. So 20 has got a lot to do with what we call Tetra volumes. This was the way Buckminster Fuller just put all this together, and the double tetrahedron is encapsulated into this. So I just wanted to conclude that there's so much more information. Even the shells around this fit 92 times and then 480. This is a universal grid of immense application in the atomic world and in the human world. So we want to use this knowledge in our human designs and improve our sacred architecture and our bodily health by living in harmony with nature. Thank you.